In this video, we will give you a more in-depth overview and demonstration of the EVDesigner Software's contrast tool. The contrast tool works by assigning a number of pixels between 0, representing black, and 255, representing white, to each pixel in the given image. At its most basic, the contrast tool simply reports back the values of certain pixels within user-defined regions. This allows the EVDesigner software to both determine the size of a dark or light region in an image, as well as determine the overall average gradient of a region in an image. While other types of image inspection techniques need to run complex equations or filters on raw pixel values, the contrast tool is simply reporting those values in their pure form. This allows the contrast tool to be one of the fastest inspection techniques. So, in order to use the contrast tool, we are first going to connect physically to a device. So I've plugged the EVDesign scan engine into my computer, and now we can connect the software to the device. So to do that, go to the top left corner and click on the Connect button. We'll get a drop-down window. We select the device that we are connecting to, and then we want to click serial device because we're not emulating a device, we're connecting to the physical one. So click connect. Now we're connected to the device. So the first thing I'm going to do is snap a picture so I get a base image that I can build my program with. So as you can see here, we have several test tubes, all of which have caps, and all of which have a varying amount of liquid contained in the test tube. What I want to do with the contrast tools is I want to measure the liquid, and I'm going to build a program that detects whether or not the cap is present. The first thing we would like to do is add some regions. I need to make some regions so the contrast tool knows where to look. So I'm going to hit the green plus, and I'm going to type in test tube 1 cap, and this will be my region for detecting the cap. Now I have a little region window that I'm going to place as accurately as I can over the first test tube's cap. There we go. Now I'm going to define a second region, test tube 1 liquid, and this will be my region that I will place over the entire test tube area where the liquid could be present. We want to make sure it's the whole test tube so that if the liquid amount varies, we can successfully capture all of the liquid. Now that I have my regions defined, I can go to the Tools menu, and I can add a contrast tool. So now we see the contrast tool has jumped into the program menus. So the first thing we need to do is tell the contrast tool where to look. So I'm going to click on Set Region and click Test Tube Cap 1. That's our first region that we defined. So this contrast tool will be detecting the cap. So in the contrast tool we have the Help menu. We have a gradient detection range. You can tell it what sort of gradient to detect or ignore. And we have a passing gradient. This is what I'm going to use. So the passing gradient will report a failure if the gradient is outside of a predefined range. So if I define the normal range of the test tube cap, it will report a failure if the gradient is outside of that range. So I'm going to select a passing gradient of 0 to 54, and we're going to see if that is roughly the same gradient as the cap. So once I have defined my passing gradient, I can send the program to the device. Now our device is programmed and I can run our program. And we can see if that is the right gradient. So the gradient tool has passed and it's detected an average gradient of 47. So with the cap in place, if the average gradient is 47, I need to turn down my acceptable range slightly so that the contrast tool will detect a missing cap if the cap is missing. So see, I've removed the cap now and the average gradient is 52. So yeah, I'm going to go back to the create menu. I'm going to lower my acceptable passing gradient range just slightly to match when the cap is in place. And I'm going to hit program. So now we go back to the run screen. And with the cap removed, it has detected a fail. It has detected a fail because the average gradient is 52. So now I can put the cap back in place, and we can run it again. And the gradient tool has passed because the cap is an average gradient of 47. Remove the cap, I can run it again. And it has failed. So now you see we have developed a simple contrast tool to detect test tube cap presence. Now we can focus on creating our liquid measuring contrast tool. So I can go down to the Add Tools menu and add another contrast tool. So this contrast tool, I have to select a region again. I'm going to select the test tube cap liquid. So now our contrast tool is looking at the correct region. And so for this, I'm going to use the gradient detection range. So pixels outside of a certain range will be ignored, and the pixels in that certain range will be counted and detected. So for the test tube, let's just say you weren't sure what region or what gradient you would be looking for. So we can define, let's say 90, or even, let's go 50 to 255, and we'll see if that works. So now the gradient tool is looking for 50 to 255. Send the program to the device and go back to the run screen. We'll scan, select the second tool, and it hasn't detected much, so we know that our gradient range is a little bit off. You can see that blue dots in the corner, that's what it's detecting. So obviously we need to change our gradient detection range much lower to get those darker values. So I'm going to change my detection range down from 0 to 71, send the program to the device, and go back to the run screen. Snap a picture, select my second contrast tool, and now it looks like it's detected too much. So it looks as though everything in the contrast region is from 0 to 71. So we can lower that window a little bit more to be more selective of what it wants to look at. Send the program, go back to the run screen, snap a picture, and now we are much more close to the real level of the liquid in the test tube. Although there's a little bit more, so I'm going to just lower the gradient detection range a little bit to clean up that detection. Program, go back to the run screen, and there, now we've detected the liquid in the test tube fairly accurately. And we can see that it has an average gradient of 31, and there are 9,261 pixels that it is detecting. So this right here is the liquid level. Our contrast tool has successfully measured in pixels the amount of liquid in the entire test tube. So we can play around with this gradient detection range a little bit to either clean it up or be a little less selective or more selective with our detection, and we'll get a slightly varying value each time. So now you can see it's detected 9,537 pixels in our liquid. And obviously this can be aided and made much more accurate by clean uniform lighting, as well as a clean uniform background versus what you were trying to detect, obviously to make those gradient values as accurate as possible. So we can remove our cap once again, and we can test that. And we can see the cap has failed. And we can also put our program on an automatic timer, and we can keep testing by removing the cap or slightly altering the image. See, I'll put the cap back, we get a pass. I'll take the cap back off again and let the program run. It's on that automatic timer. See, the cap detection has failed. And we can let this program go, and we can keep messing with the cap, and we can keep looking at the liquid level detection. It will vary slightly each time, because I don't have uniform lighting. But we have a rough value of about 9,500 to 600 pixels that it's detecting every time that we know is the level of the liquid. So this has been a brief explanation of the contrast tool in the EVDesigner software. More video tutorials are available on our YouTube page, and there you can learn about additional software features and vision tools in the program. Thank you.